All right, so today we're going to look at section 4.3, the Alabama and other paradoxes. Paradoxes or illogical outcomes can occur. They can decrease in a state's seat assignment when applying Hamilton's method once and then recalculating after a change is made to the basic elements of the apportionment problem. So the basic idea here about the paradoxes and illogical outcomes is that a change to the seats, states, and population of the given states can directly cause a change in the standard divisor that then affects the full future calculations using Hamilton's method. So essentially it's this, hey, we're going to change the population, we're going to change the seats, the states, whatever. Now everything changes. So, for example, one that you'll see in your blank handout up here for 4.3 notes, right? This is your blank handout. Um, you've got this example one that says 3 states, 20,000 total people, and the following data for population per state. So state A, B, C, total populations given. Okay, so suppose the country decides to use 200 representatives and use Hamilton's method to apportion the seats. So the standard divisor is 100 people per one representative to begin with, right? So again, 100 people per one representative. So for state A, B, C, and D, if we were to then do Hamilton's method, we will take each of their populations and divide it by our standard divisor, which is 100. Remember, you get your standard divisor by the total population, so 20,000 divided by the number of seats, which is 200, so 100. So each one is given accordingly. And remember, your standard quota should always equal the number of representatives or seats given. So 200, 200. Using Hamilton's method, we go lower quota, drop the decimals, and we have one extra seat to give out. The state that gets that extra seat is going to be state A because they have the highest decimal, giving us an apportionment of 10, 90, 100, which now adds to 200. So now suppose state C makes a request to have 201 seats instead. Where do you think the extra seat will go and why? So this is kind of like answers will vary. Your decision may change based on that. So I'll let you kind of ponder where you think that extra seat will go and why you think it'll go that way. No right or wrong, just where do you think mathematically that thing will go? And then part B, we're going to use Hamilton's method of apportionment now with 201 seats. So remember, we have to change the standard divisor because we have to do 20,000 divided by 201. So our standard divisor is no longer 100, it's 99.502. And we want to use as much as that as possible. So don't round it up to 100, right? If anything, you could round it to 99.5, but I would probably use a little bit more than that to be more correct. So now looking at this, here are our step one standard quotas, which add to 201. And when we drop the decimal using Hamilton's method, we got 9, 90, and 100, which goes to 199. So we have 2 seats to give away. Notice that the first state, which got it before, now no longer gets it. It's the other 2 states. So state A only gets 9, where now state B and C get the extra 2 seats, giving us our total of 2. Now compare what you said before. Do these results seem fair? Well, no. State B and C increase and will have more seats, but state A actually went down from the 10 that they got originally, now down to 9, despite having more seats. So this is what's called the Alabama paradox, and you can kind of figure out why it's called the Alabama paradox. It's an increase in the total number of seats being apportioned, and in and of itself forces a state to actually end up losing a seat. So if we increase, we may end up causing other states to lose the number that they had if we use Hamilton's method, which is a problem. And it's called the Alabama paradox because this happened to Alabama when we're talking about the House of Representatives. So only the number of seats is changing, and that's an issue, right? That's an issue. So we got to figure out how to maybe change that. So for example, again, in example 2, we have the following data for a continent with 5 countries with a population of 900 in millions. And there are 50 seats to be apportioned. So The standard divisor here is 18. You should be getting better at this, but again, the standard divisor is 18. So how do I know it's 18? Well, in this particular situation, again, your population is 900 million. You could put 900 million if you wanted to in Desmos, and then just simply divide by 50. But I think what we ended up doing is taking 900 and dividing it by 50, which really means it's 18 million. Okay. So here's the population in millions for each one of these 5 countries. And so here's the steps for the seats that they have apportioned. So they should all add up to 50. Using Hamilton's method, we get 8, 4, 3, 11, 16, which gives us a surplus of 2. And the 0.61, 0.38 give us the extra one. So here's the final apportionment for the Hamilton method in example 2. Now, the question that we propose is, all right, 10 years have gone by and the country recounts its populations and then wants to maybe go from there. So 10 years have gone by, the populations have increased. So if we look at this, which population is always going to increase, so this is an everyday situation. So we suppose that 10 years go by and the country recounts again. Now we have 909 million people. So which states have changed their population? Well, Alamos is fine. Brandura is fine. Canton has gone up. Dexter is good, but Alexian has gone up as well. So Canton and Alexian have gone up, which these are both the 2 countries that got the extra seats. So be mindful of that. What do you expect is going to happen in the apportionment? Well, we know that Canton and Alexian have increased, so possibly increase the number of seats that they get because it's a larger population. So that should help, right? Now, Hamilton's method with the new populations gives us a standard divisor of 18.18. Keep the decimal. You guys asked me a lot of questions about that. Keep the decimal. Now in step 1, here's our standard apportionment, still adding up to 50. Here's our steps to getting a lower divisor. Notice that every single one of the lower quotas are all the same. Still a surplus of 2. But using Hamilton's method, now we give one to Brandura and still one to Canton. So if we compared our proportionments from the first part to this part, do the results seem fair? Well, no, the population went up in Alexian and it still lost a seat, but its population increased, and that doesn't make sense, right? So that's a population paradox. Whereas before it was called the Alabama paradox, and that's whenever we increase the number of seats that we give out. Now, if we increase the population, now we've got a population paradox. So a state can potentially lose seats because its population grew. So state A loses a seat to state B, even though the population of state A grew by a higher rate, which is really weird that now I've lost a seat to you, but your population's the same and mine's gone up. That doesn't seem fair. So only the state populations can occur and change this, individual state populations. So that's one of the other paradoxes that we have. So let's look at one more example here and then talk about the last paradox. In example 3, we've got the school board decides to apportion 100 counselors to 2 high schools in a county based on the current enrollment of students using the Hamilton method. So North High School, South High School. Total population for both is about 10,000. So these are very large high schools. Looks like South is much larger than North. So North High School is going to get a 10.45, which we know we can't do that. So we'll do Hamilton's method and give North 10 and give South 89. So there's one extra seat to be apportioned here. And because South High School's decimal is 0.55, it goes to South. Now the apportionment goes 10, 90, so there's all 100 counselors accounted for. Now what we're going to do is suppose that new high school was added to the school district with an enrollment of 525 schools. The school board decides to hire 5 new counselors, just 5. Why does hiring 5 new counselors make sense here? Well, if we added 5 new ones, right, to the original, because the original standard divisor was 100, right? So 525 divided by 100 is 5.25. That means 5 is proportional. It's lower. We're not giving away more than what we needed, okay? Understand where we get all of that. 1,000, 10,000 divided by 100, 100, and then take the new number of standard divisor and divide it by the new, and that way we're essentially saying you're going to get 5.25. So when we add everything together, we get a new standard divisor. So 10,525 divided by now 105 gives us a new standard divisor. So you can see where the new decimals come into play. They're not much of a change, but they do have a change. So that adds up to 105, which is how many seats that we have. And again, you round down. So we have an extra seat to give off. Well, that seat no longer goes to South High School. Now it goes to North High School with 1 because its decimal is larger than South. That's a problem. How? Neither one of those populations changed. All we did was add a new high school, and now you've taken my counselor and moved it over to North, who doesn't have any more teachers in it. That doesn't make sense. New students in it, that doesn't make sense. So does that seem fair? No. South lost a counselor to North. Now, it would have been better if South lost a counselor to New High School, but it lost it to North, and neither one of those populations changed. So that's an issue. This is called the new states paradox. It's like when our country added all of our new states instead of the 13 colonies. Now we go to maybe the 48 continental U.S., and then maybe we start adding Hawaii and Alaska, and now there's a problem because we have to add new seats in Congress to represent them, or the House. Now, the addition of the new state with its fair share of seats added in and of itself affect the apportionment of other states. Now, the fair share is based on original standard divisor. Expect the new populations to maintain the same apportionment in fair. Okay, the number of states, populations, and seats are all changing in these paradoxes. Okay, so make sure that you type those and get that turned in.